coordination compounds, which is included in the 12th grade of all the syllabus like the CBSE state syllabus and IEC syllabus. This explanation added here, it is according to the content added in the ISC syllabus, because it is covering vast range of content related to the topic. So this is the ISC syllabus about coordination compounds, the basic introduction, where we come with different terms like ligands, coordination number, etc. Then IUPAC name nomenclature, as well as isomerism. Whenever we are learning about organic compound, the basic clear understanding till isomerism, that is actually introduction related to that group of organic compound. Now here, this isomerism is usually learned more in organic chemistry, but here this isomerism, it is coming in relation to inorganic compound, like the coordination compounds. They are inorganic compound, but they are complex compound. Because of the complex structure they exhibit, the in one molecular form itself, or one molecular structure itself exists in uh, uh, different structural arrangement. The atoms are arranged as if attaining different structural shape. So the isomerism exists in this group of compounds, coordination compounds. Once again, usually isomerism is learned or is dealt with the complex group of compounds, which is the organic compounds. Here isomerism we are learning related to the coordination compound, which are inorganic compounds. So all that come in basic introduction details related to that. Then the type of bonding in them, then certain theories related to the coordination compounds like Werner's theory, valence bond theory, crystal field theory. And on behalf of this theory we are learning certain properties like why they exist in different colors, then magnetic property of these compounds, as well as the shape of its molecule. And towards the end we are learning different uses of coordination compounds, where it is used in qualitative analysis as well as extraction of different metals, and its involvement or use in biological system. These are the basic details that we are learning here. Now first we start with certain definition, or we are trying to come in contact with certain terms related to organic again I'm sorry, coordination compound. So the ligand itself, different types of ligands. So these are the details which we are first trying to understand in detail. So here we will go coordination compounds, transition metals. Okay, what are transition metals? Now if you just consider the S block, P block and D block element, the center part of the periodic table, that is D block elements, they are named as the transition elements, and most of the elements in this group, they are transition metals. They are metallic in nature, so itself this group can be named as transition metals, right? Now these transition metal is having a characteristic property, and what is that characteristic property? They form complexes. So they involve in a certain bonding and produces or form certain complexes, right? And these complexes combine as if with other radicals to make a neutral molecule, and here we call them as coordination compounds, and they are large in number. So produce large number of coordination compounds with the complex. They form the complex radical, and these complex radical combine with the other radical, forming the compounds, right? Now we already said transition metals, but there are always the exceptions. So not only transition metals, even certain non-transition metals also involve in the coordination compound formation. Now the basic details about these compounds were first learned thoroughly in a very systematic way by the scientist Alfred Werner. So itself he is named as the father of coordination chemistry, and these compounds are specifically named as Werner complexes. So that's about certain basic concepts. Now we'll try to understand what are these compounds. Now they are molecular. They have the stable neutral molecular structure, or we can just say they are formed by the addition of two radicals, one electropositive and one electronegative. So we can call them as addition compounds. Here, what is basic present? The central metal atom, which we said could be a transition metal. It is permanently attached to another atom or group of atom, and then it forms a complex radical. Actually, it is forming a complex radical there. So here we will better understand with the help of an example. Here you can see this is the group of atom. You said, like, look, the metal is permanently attached to atom or group of atom. So here this carbon and nitrogen together, that is a group of atom. To that this metal is attached. So this is the central metal. So the central metal atom is attached to an atom or a group of atom. Here it is a group of atom, right? And this bonding is permanent. Okay, what does it mean by permanent? Even if NaCl is added into water, what will be happening? Na plus and Cl minus will be formed. Here there is no such dissociation. It will remain as a single unit. So here this iron and Cn together, it is making what? Ferrocyanide ion. As we said, it is making a negative radical. So the complex, the group of atom, and look, these group of atoms is having a special name, that is ligands. So we can say carbon and nitrogen together making a unit. So this can be named as ligand, and ligand is attached to the central metal atom, right? And once this is formed, this is a negative radical and it combines with a positive radical making a neutral molecule, and then we can call it as a coordination compound. So that's about it. Now here when we speak about this, you can see cyanide. How many units of cyanide are there? 6 units of cyanide are there, and they are bonded to the Fe. That here it is the ferrous ion, so it is bonded to the ferrous ion. Now when dissolved in water, what is that we say? Do not dissociate. When it is dissolved into the water, this will remain as a single unit. It will not dissolve to produce the ferrous ion as well as the cyanide ion. So that's a peculiar thing about this radical. Now when this ferrocyanide radical is formed, what is special about it? This ferrocyanide radical will not be having any property of ferrous ion or cyanide ion. It will be having totally different property. So thus, if we add it into water, there will not be any action seen or observed as if when iron is added or when cyanide is added, because this is having this ferrocyanide radical is having quite typical properties which is different from that of the ferrous ion as well as the cyanide ion. Here, so we were discussing about the coordination compounds. Now another group of complex compound, that is double salt, which you have learned in maybe in your 10th standard. Here we will just try to have a clear idea about what is the difference between the double salt and the coordination compound. Now here these double salt and coordination compound, what is the similarity? Both are molecular or addition compounds, and they are formed by 2 or more salts in a stoichiometric ratio. There is a ratio between the different components present in it. And what is the difference is that they differ in their ionization behavior in aqueous solution. When they are added into water, how they behave, that is different, and that is the basic difference between the double salt and coordination compound. We will try to understand much more detail using one example. Look, double salt, it exists as addition compounds in solid state, and when it is added into water, it dissociate. Like it completely dissolve and dissociate, and it will lose its identity. Okay, we'll just go with more salt, which you may have heard before, like ferrous sulfate, then ammonium sulfate and water molecule, this together making an addition compound. This is a double salt which we name as more salt. Now how it is produced? It is produced by mixing saturated solution of ferrous sulfate and ammonium sulfate. So you can see saturated solution of ferrous sulfate and ammonium sulfate. It's just mixed together, and in very low temperature it will make a chemical addition product, and we get the more salt. Now this more salt, when we add into water, what will be happening? It will first dissociate, it will just dissolve first. So all the different components will get separated, like the ferrous sulfate, ammonium sulfate, etc., and each of this component will get ionized and it gets dissociated. So here you can see the ferrous sulfate dissociate to produce ferrous ion and sulfate ion. Here ammonium ion and sulfate ion. So likewise it will dissociate, ionization and dissociation takes place. So you can see ferrous ion, ammonium ion, sulfate ion, and these ions will be suspended in water or just remain in water. So that's about here. The now if we just take us in a test tube, if we take a small amount of the solution and do the test for ferrous ion, ammonium ion as well as sulfate ion, all will be answered positive, which helps us to understand that all the ions or these the components has got ionized and dissociated and ions are present in the solution. So that's about one example for a double salt. Here another one example, which is potash alum, which is used for the coagulation process while in one step in purification of water. So what is that? Potassium sulfate, aluminum sulfate, and it's a hydrated salt with water of hydrization, that is water of crystallization, that is 24 molecules of water. So this when added into water, what is happening? There will be potassium ion, aluminum ion, sulfate ions, as well as these ions will be suspended in water. So here also we can see what each of the component gets separated, gets dissolved, gets separated, and each of the chemical will get ionized and the ions are dissociated in the water. So that's about potash alum. Another one double salt, that is carnallite, potassium chloride, magnesium chloride, and with 6 molecules of water together. So that's one example. Here also the same process happens. Now ferric alum, another one addition compound, double salt. So here also the same process happens. So that's about how the double salt behave when it come in contact with water. Now we will just see what is happening for the coordination compounds. These are also addition compounds, but they retain their identity in aqueous solution. So that's a different thing about coordination compound. They retain their identity in aqueous solution, right? Now, if we just consider, like here earlier we said each of the ions will be present and the solution will show the or answer the test positive for each of the ion, but here the ions will not have will not retain its property, or the presence of those specific ions will not be answered positive. So shows properties entirely different from constituent ions, like here potassium ion, ferrous ion, cyanide ion. Likewise we will not be able to, or the solution will not show answer for each specific ion like that. Now when it is added into water, what will be happening? So this is potassium ferrocyanide, and how it is formed? It is obtained by mixing the ferrous sulfate and potassium cyanide, and we will be getting this first we will be getting ferrous cyanide and potassium sulfate, and when it is just kept for some time together, there will be a complex formation between them, finally producing ferro cyanide ions in the solution. You can see ferrocyanide ions in the solution. Now, so potassium ferrocyanide in the solution. So when it is in solution, what will be happening? Here there will be ionization and dissociation happening. So the potassium ion will be produced and the ferrocyanide ion will be produced. Now if we just dissolve ferrous sulfate in water, there will be ferrous ion and sulfate ion. Here potassium ion and cyanide ion. Then these are allowed to combine together to make a coordination complex. So first what is produced? This ferrocyanide is produced, and then again it is kept for dissolving, and finally it produces a complex addition compound, and that is potassium ferrocyanide. Now this potassium ferrocyanide, once the stable molecule is formed, this stable molecule of potassium ferrocyanide, if we just add it into solution, or if we add into water and make a solution of this compound, what will be happening? You can see the potassium ion will be produced, but ferrocyanide will remain as a single unit. It will remain as a single unit. Ferrocyanide, it is a complex ion and it retains its identity, and it will not, or it does not further decompose or dissociate to produce ferrous ion or cyanide ion. So that's a basic difference of the coordination compound from that of double salt. And here you can see potassium cyanonickelate, potassium cyanonickelate. So this when added into water, what will be happening? The tetracyanonickelate will remain as a single unit and potassium will get dissociated. So that's about the difference between the double salt and the coordination compound. Next it comes different terms, very important terms. Once the clear understanding of these terms is not gained before we start in detail with the topic, it will be a bit difficult for you to understand. So we will just continue explaining the terms of coordination compounds.